Okay, so this is your number 2 in the homework, and it might not be that you have a graphing calculator. So there is a free program online. I'm going to go there. It's called Desmos. And if you go there, you can use it. You could just click on the graphing calculator, and we can put this function in. And I don't think it allows me to copy and paste, so let me go back to the problem. So I'm just going to put in 23 over x squared plus 4. And you have to kind of use the caret to do a power when you use Desmos. Your little caret is, it's above the 6 on the keyboard. All right, and let's notice that there's the graph of what that thing looks like. All right, so let's just answer the questions based on that graph. So if I go back here, increasing and decreasing. All right. Now on Desmos, you can sort of hover your cursor and notice that we can see that that point right there at the top is 0, 5.75. So it's increasing from negative infinity out here to 0. So we'll put, remember, you list your increasing and decreasing by the x values, not by the y values. And somehow I got an extra parenthesis in there. And then it's decreasing from 0 to infinity, the other half of the graph. All right, now it has a maximum at that point. The maximum is at 0, 5.75. So of 5.75 at x equals 0. So you notice as we put that little x equal there, tells me we got to put, and the maximum, when it listed that way, maximum of will always be the y value. Now minimum, we really don't have a minimum. If we look at the graph, this is getting smaller and smaller and closer to the x-axis, but it keeps getting littler and littler without reaching it. So, you know, we might have a y value of a half, but then a value of a third, and then a value of a fourth. It's not possible to list the smallest value. All right, and then, so we leave that blank because it said, if any of the above do not exist, leave the answer box blank. The domain, let's notice that this, if we were to squish it onto the x-axis, everything would get covered. So our domain is negative infinity to positive infinity. And then our range, if we look at this thing, it never crosses the x-axis. So it goes from 0 up to this point right here, 5.75. And 0 is not a point on the graph, so we want an open circle, whereas this one is a point on the graph. So it's going to be a closed bracket. So we want 0 to 5.75, closed bracket, whoops, closed bracket, and let me get rid of that right there. And that would be what we have on this one. And of course, yours might be slightly different from mine when you regenerate it. Now let's take a look at your 4. All right, so they've gone and factored this thing for us, which makes it a little nicer. So the first thing we want to do is draw the points on the x-axis that are the x-intercepts. To get x-intercepts, we set the top to 0. Now, since they've factored it for us, the truth is all we've got to do is set x minus 4 to 0 and x plus 2 to 0. And this is going to give us a positive 4 and a negative 2. So I want to plot both of those. Now, I need to be using the draw feature, but it won't let me use the draw feature while I'm using this this version that is a Google add-on. All right, and then draw vertical lines as the vertical asymptotes. Our vertical asymptotes we get from the denominator. So if we set both of these to 0. Now remember, with vertical asymptotes, once we solve these, we have to put them in the top and make sure they don't make the numerator 0. So this gives us 1, and this gives us -1. And if we check that in the numerator, check a 1, well, 1 minus 4 is not 0, and 1 plus 2 is not 0. So this one's okay, that is a vertical asymptote. And if we check -1, -1 minus 4 is not 0, -1 plus 2 is not 0. These are both vertical asymptotes. So it says to draw the vertical lines. So we would want vertical dotted lines at 1 and at -1. And actually, they may here just have you draw them as regular lines from the looks of it, rather than dotted lines, because it's just having you draw these asymptotes. And then the horizontal asymptote. Well, let's go back to the original here. There's really a -2 in front of this x squared if we think of that -2 really being right there. So this is a -2x squared, and this is an x squared down here, and they are the same exponent, same degree. And recall, if they're the same degree, our horizontal asymptote is the numbers that are in front of them. So there's a -2 in front of this x squared, and there's really a +1 in front of this x squared. So our vertical asymptote is y equals -2. So we'll go down here, and then we want at -2, we want, I said vertical, horizontal asymptote is at y equals -2. And that's all you need to draw here, because it does not say to actually graph the function.